Hi, I'm Dr. Thomas Barrows, and I'd like to present to you today cavitation ultrasound. I'm going to be talking a little bit about what ultrasound is, the history of it, and a little bit about the technology, and then in particular what cavitation ultrasound is and how we can use this in cosmetic medicine. I'd like to first begin by explaining what sound is, and then we'll talk about infrasound and ultrasound. Sound is the compression and rarefaction of waves through a material, and it can be through a gas, a liquid, a solid. Obviously in space you can't transmit sound because there's no material to compress. Sound itself, acoustic sound, what we normally equate to sound, is a range of compression frequencies that are detectable by the ear. The range of frequencies that humans can hear begins around 12 hertz, which is a very low, deep bass frequency, and goes up as high as 20,000 hertz. That's an age-dependent process. As our ear gets older, the hair fibers that will detect sounds diminish, and we have less sensitivity to higher frequencies. Many adults can't hear above about 15,000 hertz, which has led one entrepreneurial company to develop a device called the mosquito anti-loitering system. And this device emits a high amplitude sound waves in the range of 17 kilohertz. Children can hear them and they hate it, and it allows you to drive them away from your storefronts, and adults can't hear that sound at all. Dogs, for example, can hear in much higher frequencies. In comparison to acoustic sound, what most people equate to as sound, there are actually compression frequencies that are too low for us to hear, and these are referred to as infrasound. And then, of course, above the frequencies that we can hear are referred to as ultrasound. Within ultrasound, there are low-frequency ultrasounds in the range of 20 kilohertz up to 1 megahertz. It's in this 20 kilohertz to 1 megahertz range that we often find cavitation devices. Furthermore, the frequency that is used can affect the depth of penetration. The higher the frequency, oftentimes we get better resolution, but less depth of penetration. Most people normally think of ultrasound as diagnostic ultrasound that one might use to look at a pregnancy. Diagnostic ultrasound for pregnancies was actually a much later invention. Ultrasound's been used for many years in such fields as microscopy as well as for chemistry applications. And in particular, the use of cavitation in chemistry allows one to create novel compounds that can't be created in other ways, such as metal carbonyls and other bizarre structures. Furthermore, ultrasound's been used to measure flow rates in liquids, and this is particularly helpful when we use color flow or Doppler studies. And this also has found medical applications in which one can look at arterial flow rates and for the presence of venous thromboemboli. Winston Churchill once said that we can only see as far forward as we can see backwards. And for this reason, I always like to present a little bit of history when I'm talking about physics or medical devices. And so let's give a little credit to the invention of ultrasound and the description of the terms cavitation to whom they belong. Lord Rayleigh was one of the first scientists to describe cavitation in liquid. He found that if one causes a rapid pressure drop around a liquid bubble, that there would be sudden collapse and increasing pressures and temperatures within the bubble. This was a prerequisite to understanding ultrasound-mediated cavitation many years later. Lord Rayleigh even gave us an explanation as to why the sky is blue, and went on to win a Nobel Prize for his work that resulted in the discovery of argon, amongst many other impressive contributions to science. There were many names that are associated with the invention of ultrasound, and it would be really quite impossible to introduce all the people who contributed greatly to this field. But there are a few scientists who stand out in my mind as deserving some degree of credit. The first is Dr. Loomis. And Loomis was an interesting character. He started out life as a mathematics major, but then went on to become a billionaire nearly 100 years ago, when that was an astonishing amount of money even today. And he really became the rich and idiosyncratic playboy that we all wish we were. Not only did he become very interested in ballistics, but he set up a secret laboratory that became a meeting place for some of the great minds in physics, including Albert Einstein, Niels Bohr, Werner Heisenberg, James Franck, and Enrico Fermi. And many of those names you'll recognize as being involved in quantum mechanics and even having participation in the atomic bomb development. But furthermore, his lab conducted research into sound waves and spectroscopy. In isolation from Loomis and the American scientific community was Dr. Langevin. And Langevin was very much interested in the outstanding studies of Pierre and Marie Curie's piezoelectric effect. And of course, they were famous for the discovery of radon and X-rays. But Langevin was interested in submarine detection, and he realized that the piezoelectric crystals that the Curies were studying could be used to create sound waves for that purpose. After Pierre Curie died, not only did he work with Marie Curie, but he had an affair with her. They were quite close. He became subsequently an outspoken opponent to the Nazis, who by that time had established the Vichy government in France. So the Nazis ran him out of his post. Wood, on the right, is best known for his work in ultraviolet and infrared detection, and he is one of the pioneers of ultraviolet photography. He's also the inventor of the Woods lamp, which is still used in medicine to detect various substances, and plenty of teenagers who still like to use blacklight photos. Wood discovered the work of Langevin and brought it to Dr. Loomis's lab and suggested that it may have many more applications than the scope of practice Langevin was working on. Subsequently, through Loomis's lab, they were able to discover the way to induce cavitation with ultrasound, which they brought to the field of chemistry with tremendous results beginning in about the 1920s.